Hello, welcome back to Ready Controls. Have you ever wanted to track products on conveyor or move signals step by step in your PLC program? The secret is in two powerful instructions, bit shift left and bit shift right. These instructions don't just move bits, they are foundation for applications like product rejection, sequence indicators, and even light chase effect. Today we'll focus on the basics so you'll be ready to use them in the projects. I still remember my first time using a bit shift instruction. I was trying to reject faulty bottles at the right spot on the conveyor. Timers weren't reliable. Once I learned how to use the bit shift right instruction, everything fell into place. From that day onwards, I became a fan of bit, bit shift instructions. What you will learn in this video is about how the bit shift left and bit shift right instructions work in Studio 5000 and how to set up instruction. So this is how the bit shift right works. So here is the array before the shift. This is a 32-bit word dint element 0. This is that array 0, right? Um, so what we are saying here is length of 4. So I highlighted we are working on bits 0 to 3. Those are 4 bits, 0, 1, 2, 3. So when enabled, the BSR copies 0.0, it will take this 0.0 bit, puts them into an unload bit of the control word, which is array underscore BSR. It will unload it and shifts the bits to the right. So what it does, it since this is unloaded, it will go ahead and shift this 101 to the right. So these get moved into here. You could see the bit before one was in bit position 3. Now that one is in bit position 2 and 0 was into 0 is in now 1. So you could see this 3 moved to here. Everything shifted by 1 bit, and 1 moved to 0 here, and this one moved to here. So everything moved by 1 bit. And then what it will do is it will take whatever we give in this source BSR, right? That's a 1, and that will move into the 4th bit. Oh, sorry, the 4th bit, which is nothing but the 3rd location. So that's how a BSR works. Okay, we'll demo this out in the video, but that's exactly how it works in 3 steps. Now if we go back, same array, if we do it in the bit shift left, it works in the opposite direction. It moves everything, it shifts everything towards the higher index, right? So what it does, same array, I just use the same example. So our focus is the 4 bits, so 1011, right? So when enabled, it will always start at bit 0. The instruction unloads dot 3 bit, because now we are moving towards higher radiuses, right? Higher indexes. So it will take the 4th bit, which is nothing but this bit. So it will take the 4th bit, which is in the 3rd position. It will unload it first and then take the remaining 3, shifts them to the right. That means this 0 will go into, which was on the 2nd position, now went into the 3rd index, and then this 1 moved there, and this 0 moved it into the 1st position. Okay, and then it will take whatever we give in the source bit into this 0th position. Okay, that's how bit shift left works. Okay, now we will showcase the same in the logic. So now let's look at the bit shift right instruction in action. This is the bit shift right. I have some arrays. I just created a array of 10 registers here, 10 array of 10 DINTs, and I have a control word called array underscore BSR, and a source BSR is nothing but just a boolean with a value of 1, and we want to do length of 4, right? Say based on what we saw in the Excel demo, I loaded the same word into the here. So we'll be working on D into 1. So you can see 1011 and 1010, right? Now let's look up live what will happen when we toggle the bit, right? So as BSR, we know it will copy the 0.0. So we'll go ahead and toggle it. Once we toggled, what happened is it unloaded. So let's look at the reference. Before it was the 4-bit was 1011, but now you could see it unloaded this one into unload bit, and it shifted 101 by one position. So this 101 came to here, and it loaded 1 into the 4th bit. So that's how a BSR works. Now let's look at a BSL, how a BSL works, right? Same thing, BSL, what it does, it moves everything towards the left. What it does is it will unload the higher radix, which is the 4th bit, that is bit 3 here, 0, 0, 1, 2, 3, 4, 4th bit. It will unload it and shift the remaining by one position and load a 1 into it, right? So what it does, I have to repeat. So BSL just shifts everything to the right? So it will unload the bit 4, which is in our case it's the 0.3, and then it shifts the remaining bits 0, 1, 2 into by one position to the left and loads the source bit into 1. Okay, so I can make this smallest so we can see. That's how it should work, right? So let's look up a live demo. So I got the same instruction, but this time it's a bit shift left, and I'm using D into 0 here. So we'll go ahead and unload, minimize this one. Sorry, minimize the array BSR. We need array BSL, which is our control word. So I'll just reset. Sorry, I'm just resetting the control word, position it up, and now let's see if I got everything arranged. Okay, so now I got this one. So we're focusing on this one. So when I toggle that bit, you could see everything shifted towards the left. Okay, let's go back, look at our sheet for reference. You can see we had 1011 to begin with. Now what it did, it took that one which was in the before, it moved it into the .ul, and then took 110 or 011, moved it to the left by one position. So that's why you have 110 here, and then it took the source bit, put it onto the 0th position. So that's how a bit shift left instruction works. So we have covered in detail about both the bit shift left and right. Just think about these instructions. Think of it like a moving conveyor of ones and zeros. With every pulse, either the bit moves one step to the left or one step to the right. And in how many groups is it is defined by the length of it, right? You can move a group of 4 ones or 4 zeros or 5 or 6, depending on how many positions you have on the conveyance, right? So if you have a conveyance which is indexing 10 boxes, then your length will be 10, and each position can index, right? So this is how you use a BSL and a BSR instruction. You will need an array of bools for your data. So it could be a light chase where you want to have a light chase effect, or you want to move parts on the conveyor. Overall, we covered these instructions, how they work, and in the next application we will talk about real world applications like rejecting bad parts on the conveyor or creating a light chase sequence. If you like this video, please share and subscribe, and share the channel with other engineers, and comment if you want similar content. This video is actually from a comment from one of my subscribers. So thank you. Until then, I'll see you in the next video. Bye.